Hello everybody. Today's video is talking about improper integrals. These are something that's usually dealing around infinity. So it shouldn't be too difficult to deal with. It should be nice and quick, unlike what infinity actually is. Alright, so what are improper integrals? Well, there are a few different situations that they might arise. First of all, if one of your bounds is infinite or infinity. In this situation, you'd have something that looks like the integral from a to infinity of f of x dx. Well, how we do these is integrate it, then plug in our values, but you can't really plug in infinity. So what you do is instead is change it to the bounds from a to b, but b is going to infinity, so you take a limit. So a slight little change there. So you're still doing the integral like normal, and you're still plugging in values, but then you're calculating a limit beyond that. So yeah, we use limits to find derivatives. Now we're finding them to find integrals. All right, so that's if one of your bounds is infinite. If two of them are infinite, you need to split your function up over the two separate bounds. So if you're going from negative infinity to infinity, you go negative infinity to some value, start from that value and go to infinity. And then you turn it into two separate improper integrals, bring out the infinity and taking limits. All right, so you're still covering the entire range. You just split it up. And you can choose wherever you want to split it up. Most of the time, the easy split is at 0. Depending on what your function is, it might be easier going with something else, but in general, 0 should work. And then there's one other possible situation, and that's if your function becomes infinite at one of the bounds. So if you have a function where if I put b into it, it becomes infinity. Well, you want to change your bounds then from a to r and have r going to b from the left side. And you consider what that comes out to. So it's one of those where you have to keep in mind what happens to your function at your bounds. So quite one of the major situations would be if you're dividing by x. Well, if x is 0, you can't actually put that in, so you'd have to integrate it as your x is getting closer to 0. All right. Now, it'd be a similar situation if a was the one that made it infinite, in which case r would be approaching a from the positive side. So that's all there is to improper integrals. So let's go and take a look at an exercise. So go ahead and try and find the integral of this setup. All right. Hopefully you paused it and tried it out. The very first step, change it from the improper to a more proper one. All right. From here, it's a pretty straightforward integration problem, which I'll give a few moments in between each one. So if you want to pause between each step. Now don't forget, you need the 1 and the b to be the bounds of integration after you've done the integral. Plug the values in. And then you get something like this. All right. Now, the limit is still going to infinity. So you have 2, which is just a constant out at the end, but then 2 divided by the square root of b. Well, as b is getting bigger and bigger, the square root of b is getting bigger and bigger. And if you're dividing by a larger and larger and larger number, eventually it will go to 0. So this one comes out to 2. All right, and that is improper integrals. Told you nice and quick. I'll see you on class on Wednesday.